Hello everybody, I'm Cătălin Tudose. So the topic of the presentation is the financial data integration, which is an important problem into the today's software. Here you can see the contents of the presentation. We have addressed 5 big chapters: the problem of data integration, the architectures of financial data integration, the data transformation using Apache Camel, which is a special framework designed for data transformation and integration. We are also going to discuss a little about applied enterprise integration patterns, and we are going to show how behavioral-driven development is used for financial data integration application. So we are going to have 5 topics that we are going to address within this presentation. The first one is the problem of data integration, and it originates, of course, from practical problems. In many cases, you cannot build a complex system from the scratch because it is very costly and in most cases it is not successful. In most cases, you will prefer to assemble the system from the existing system that you have, like a puzzle, and you would like to integrate the existing components. But usually, the pieces of the puzzle are made in order to match each other, while the systems themselves rarely integrate with one another. That is why the data integration focuses on this interoperation and on this integration of the systems. About financial data integration architectures, they are designed also for practical reasons. The companies that work in financial service always require immediate access to high quality information. You know that in financial services you need to move at a high speed, and the data that is the raw material to produce the information has become more and more diversified and distributed. So the companies are required to optimally combine their business processes with the right tools and technologies in order to respond quickly to customer demand, to market opportunity, and competitive threats. This challenge is a difficult one. That is why the problem of financial data integration architecture is a very important one. And in most cases, as I was saying, you need to integrate some data from a provider in order to send it to a final target system. And here we show how a typical financial data integration architecture looks like. Usually, you are required to acquire some data from an external data delivery platform. This platform may provide a large variety of data, so you are acquiring data from here. You need to design and to implement such an interface that will make the communication between this provider and the target system. And of course, the destination of the processed data is this target system, the system where we are sending data. So the challenge in most cases is to design this interface that allows the communication between the external data system and your own target system where data are to be sent into the desired format. In most cases, data that you are acquiring is not purely and simply saved into your own system. It needs some processing And for this, we need to define some mappings. And here we are going to explain what mappings mean. Here we have the external provider fields, meaning that the external provider, the data that is acquired, will show us field 1, field 2, a number of fields that are significant for that external provider. This is the data that we are acquiring. And we would like to arrive to the step when we save the data within our own system, but with fields that are significant for our own understanding. So here there is not a perfect match between the fields that are acquired from the external provider to the fields that are significant for ourselves. It may happen sometimes that there is one-to-one correspondence. This is possible. But in other cases, we need to process this data. We are using what is called mappings or functional mappings. Here we are showing the situation when from 4 fields that are acquired from the external provider, we are constructed our own significant field that we are sending to the target system. So a combination of these external fields will give us the value of our own field. These are fields that are significant into the external system. This is a field that is significant into our own system. And there may be situation when there is also a one-to-one correspondence, but we need to pass through some settings. This means that we need to take a look at some particular settings that tell us how to process data. As a very simple example, you may take some data from here, and according to some settings, you may save it into your own systems in month, day, year format, or in day, month, year format. This is according to the settings from here. So this is the logic, the large overview of how these mappings and how this data processing is made in order to make the data processing and acquisition successful. And so we have addressed the large ideas of problem of data integration and the financial data integration architectures. We have pointed the main ideas in order to make understanding of how these processes are going to be implemented. We move to the data transformation using Apache Camel. I was saying that Apache Camel is a framework that is specially designed in order to make this integration process more powerful and more quickly. This is a framework that intends to simplify the life of the programmer that activates in the field of data integration. And at the core of the Camel framework, there is a routing engine builder. You have some data that you acquire from a source, as I was saying, and you are trying to route this data and to process it in order to arrive to some destination. And at the core of the Camel framework is this routing engine builder. Camel allows to define routing rules, and Camel will know from which sources to accept messages and will know how to process and send messages to other destinations, and of course to the final destination where you will save your data. In order to do this, Camel uses an integration language that allows to define complex routing rules. We are going to make a demo quickly. Just to add here that Camel, important is that Camel makes no assumptions about the data about the type of data to process. This means that KML is not looking at the fact that you are having data as XML, CSV, text, or bytes, or no matter what. KML will know to process this data with no assumption about the type. Also, KML comes with support for over 80 protocols and data types. When I'm saying protocols, as example, we may have the FTP protocols, the file protocol, meaning the way we are able to acquire the data. And we are going to do a small introductory demo. Here, we are going to show how you are doing a very simple processing, that means only copying a file. You may wonder why you should use this KML Apache framework when you can do some operations by yourselves. Of course, there is an input-output library that is being shipped with Java, and you can use it in order to make some processing, in order to take data from some source and to route it to some destination. This is perfectly possible, and here we have prepared for our demo some financial data that will show us how this is done. Here we have some securities or some financial instruments that you may have heard about. There are some classical securities of this kind, widespread, which are bonds and equities. Here, for our demo, we have prepared a bond like CSV, a bond as XML. This is a very simple and fictitious bond that we have shown here. Also, there is a financial instrument that is called equity that we have prepared here into the CSV format, and also an equity prepared into the XML format. And for our demo, we are going to work with this data and show how it is processed. Also, we have here some bad data that will help us to show how errors are processed. For the beginning, I was saying that we would like to show how a very simple processing is done with our classical instruments, with our classical Java libraries, with our classical input-output Java libraries. And here, this is a piece of code that may be familiar to you. We are trying to acquire some data from this folder, data securities, meaning this, and we are trying to save it, just copy it into the output or destination directory. And this is a piece of code that is doing it. You may remark here that you need to create the directory by yourself, to take a look at the files that are existing into the source folder, and to process it piece by piece. You need to write your own copy file in order to specify the source and the destination. You need to handle by yourself these streams, and you need to try and close by yourself the streams. You do not have to forget all these operations. This is a piece of code that works, but it is pretty big for such a simple problem, and in plus, it does not guarantee that as long as something is changing here into the folder, it will work. You will also need to track the changes inside this folder. Let's try to run this. and we take a look at what has happened here. Of course, we have here a new folder as we have defined it and created it manually. It has been created and it has copied all files from the original securities folder to this outbox folder. And we said that it works. But we are going to take now a look at how the same thing is done with Apache Camel. Here you may already remark that there is a simple piece of code that has been written. The code needs to do the following. We are defining a new Camel context, which is a container that will where we will put everything into, and we are going to discuss a little later about this. We are defining the roots, and the root says here we are taking from this source, and we are going to send all information to this destination. Here it is very easy to understand how the framework is written. Even if you have never met Camel, you are able to understand immediately that we are taking something from here and we are routing it to here. We are defining this route. We are adding it to this container that is the context itself. We are starting the context and we are waiting for 5 seconds. After this, we are stopping it. Here, we are telling the context, we are telling Apache Camel to take the information from the file with the file protocol from the data securities folder. No operation equals true means that we are not going to move the data. We are going to leave it. We are just copying it, and we are routing everything to this data outbox folder. And in order to make the demo, I am just going to delete the old outbox folder that has been created with the classical copier. I am going to start this copying. Here we are showing some Apache Camel logs. We are going to take a new look here, and we have made the same operation, but this time Apache way, and I think that the advantages are already remarked by the user. Here, just taking a look at the length of this code and the length of this code. It's already smaller. So this was the first demo that shows the advantages of using such a framework for data integration. Okay. Going back to the presentation, and we are going to say a few things about the Apache Camel framework itself and about how it has came into being. So it has been built in order to make integration more productive. Projects that will need Apache, that will use Apache Camel, will be much more productive than projects that use the classical way. This project has been started in early 2007, so we may say that at this time, 8 years after, it is already a mature open source project, and it is available under the liberal Apache license. Which are the main ideas behind this Apache Camel framework? First and most important, it is a routing and mediation engine. Routing and mediation means that you will be able to route your data to whichever destination, final or intermediary, that you would like to. And you will be able to mediate in the sense that you can process, filter data. It is heavily based on what we call enterprise integration patterns. When we speak about patterns, probably your first idea is related to the design patterns, to the classical design patterns. A design pattern uses to solve a problem that is almost classical. That is a design problem. Here we also have integration problems that have become classical. So this means that when solving integration problems, the people that have done this have noticed that some problems are repeating and repeating themselves. So like into the design patterns, there has been some effort in order to define some ideas that are repeating. This is useful first in order to communicate how a problem looks like, and then after that we communicate a problem that is repeating or is similar to something that we have already seen, we can approach it the same classical way, meaning that we already have a recipe to solve it. So this is an enterprise integration pattern, meaning that many problems are repeating, and KML itself, the framework itself, is heavily based on this defined enterprise integration patterns. Then another idea behind KML is the domain-specific language. We have seen that KML is defining some proper language, saying from, to, and many other things that we are going to see a little bit later. So this is a domain-specific language. We are coming with our own definitions. KML is also able to provide a component library that is also extensible. We can define our own library of components. It is a payload agnostic router. This means that, as I have previously said, it doesn't care what it is carrying. Data may be in any format, and KML will just not care if it is an XML, a CSV, or anything else. It has a modular and pluggable architecture, so it is easily extendable. This is crucial for any framework. Also, it relies on the POJO or on the bean model. You know what beans are in Java. They are classes that can be reused, and we will also show how we can use these POJOs for our integration. It is also easily configurable. It has some automatic type converters, meaning that you can convert from one format to another automatically, or if some format doesn't have a type converter that is already defined, you can define your own type converter. It has a lightweight core, meaning that if you download it, the latest version will be less than 2 megabytes in order to be installed. It provides an important test kit, a large test kit, and this is crucial for any integration framework. This is because you are always trying to take data from some source, process it, and send it to a specific own format. And you need to verify that the data that you have processed has arrived into a desired format. This is based already, you may already be familiar with what TDD, test-driven development, is. KML goes somewhere further. It provides a large test kit, as I was saying, testing and making sure that everything runs fine and you are getting the data into the desired format is absolutely crucial. And last but not least, KML Apache has already a vibrant community, meaning that during these 8 years, while it has been developed and used, it has always gathered around it some communities that can support you if you have some problems. If you are using some small framework that has only a limited number of users, then if you're running into problems, you will be on your own. But that is not with KML. That is not for KML, which has already a lot of users that have experienced a lot and can share knowledge and information with some others. This is a high view of the architecture itself. I was saying when I have run my first program that there is a KML context where everything gets embedded. KML context is like a container where you will insert everything. You will insert the roots, and you will have the components, you will have the processors. You may define everything there and embed it into this KML context. In fact, this idea of context is nothing new within programming and within Java programming. We are just pointing it out here that there is a KML context that acts like a container that will hold everything. Everything that needs to be known at a certain moment will need to be defined and embedded into a certain KML context. Here is another view of this KML context. We see what it may contain. I was already saying I have talked about roots, which are very important and tell us from where to route the data, about data formats, languages, because I was saying that we have a domain-specific language. We have registries. We have type converters, already discussed about them. We have some components and endpoints. We are going to briefly point them into the next slides. I was talking about components. Components that are used mean by, as an example, the file component, the FTP component, the JMS component, in order to point out some very common and something that you may already be familiar with. Components act like a factory of endpoint. In order to be able to make communication, you need some endpoints. Components are the ones that create the endpoints and make the communication and the routing possible. I was saying that there are a lot of components that are already defined within KML, but of course you can define your own component. Also, a very important concept, and we have already mentioned it, are the roots. The roots that have been added into the KML context will tell us how to make the routing from which source to which destination. We may have an input source, we may have a final destination, but we may have some intermediary nodes in order to make some processing. You can imagine the roots like lines inside the graph that connect some processor nodes. We have the type converters. I was saying that KML is able to do the type converting from one format to another automatically if it has already defined this type converter, or if it doesn't have a type converter, you may define your own type converter. Also, the data formats are known inside the KML context. There is also a registry that allows you to look up beans or POJOs. I was saying that they are also important and in KML. And we have the loaded languages. Let's say that KML is able to define its own roots and consequently its own behavior in a few ways. We have shown that domain-specific language this way. This is a language that is designed to define the roots and to make them add to the KML context. But this is not the only way. There is also a possibility to define the KML context and the roots in some Spring way. We are not going to discuss this in detail. I'm not going to use them for the demo, but for the moment, just to be aware that there may be different languages that may be used in order to define the same context and the same roots. What's behind everything here? It's the routing engine. KML has a routing engine that is the one that actually moves messages under the hood. You will not see it. You will just define your context. Will configure it with adding routes and everything you will need. But the engine itself is not exposed to the developer. You just should be aware that is there and that it ensures that messages are properly routed. This is in the spirit of what we already know as the important inversion of control concept. You are just defining the behavior, like this simple behavior, and in our case, the routing engine will take care of everything. You just have to define this behavior. I was talking about the roots and I was saying that they are very important. Without roots, you cannot move any message. And if you would like to imagine the roots, how they look like and which their destination is, you can imagine a graph. You may imagine the lines or the arcs inside the graph that will connect the processors. The goal of the roots is to decouple the clients from servers and the producers from consumers. You would like to allow clients and servers to be developed independently, and also for testing purposes, you would like to allow clients and servers to use mocks. In many cases, when you would like to make some testing, you may consider using mocks just to simplify your life, your work. When you define a route in KML, it has a unique identifier that is used for logging, debugging, monitoring, and starting and stopping that route. A route has exactly one input source for the message, and you can route that message to one or more destinations. And I was saying, in order to define a route, there is a domain-specific language that is used. In our case, this is a little piece of domain-specific language. We are going to see more into the examples to come. This is something a little more extended than the simple from to route that you have seen. Here, we would like to wire two endpoints to send data from here to a file, to here to another folder, but to filter it according to some condition. And this is one example one step forward to the example of the domain-specific language. And what you see here is something very common and that you will be able to use or encounter in many KML projects. What is a processor? The processor is a node into the graph that I was talking about. Many of the processors are implementations of EIPs, of Enterprise Integration Patterns. I was saying that KML is heavily based on the EIPs, and the designers of the Apache Camel framework have tried to implement almost a one-to-one correspondence between the concepts of the enterprise integration patterns and the processors that they have defined inside the framework. I have already discussed about imagining the processing like a graph. So let's add one more thing, one more time, that in our KML context, routes correspond to the arcs and processors correspond to the nodes themselves. And I was saying in most cases they are implementation of enterprise integration patterns. A component is the main extension point in KML. I was saying that there are already over 80 components in KML, and that you can create your own components for KML. Examples of components, you may remember that there are the file, the FTP, the JMS, and they are always associated with a name that's used in a URI. I have already said that they act as a factory of endpoints. Here is an endpoint that is a KML abstraction that models the end of a channel. When you arrive to an endpoint, it means that you have arrived to an end of a channel. And in order to configure an endpoint, you can use URIs. Here, you see that the protocol uses file, and the data is taken from this folder. And here you also have the option of a delay of 5,000 milliseconds. This means that you are going to poll this location looking for files every 5 seconds in order to see what is new and to process it. Also, a KML context defines producers. A producer is a KML abstraction that refers to an entity capable of creating and sending a message to an endpoint. When a message needs to be sent to an endpoint, the producer will just create the exchange and populate it with data compatible with that particular endpoint. You just need to route the message to endpoint, and the producer will know what to do with it and how to treat it. And of course, if we have producers, we need also to have consumers. Consumers are the source of the exchanges that are being routed in KML. And in order to create a new exchange, a consumer will, of course, use the endpoints that wraps the payload being consumed. And we need to keep in mind that we have two kinds of consumers. We have the event-driven consumers. When something happens, the consumer will act and consume that message. And we have a polling consumer. A polling consumer is a consumer that is periodically checking in order to see if something else needs to be consumed. And this way we have treated the basics of data transformation using the Apache Camel. We are going to move one step forward to the enterprise integration patterns, and we are going to do some more practical demo. I was saying that KML is heavily based on enterprise integration patterns. And an enterprise integration patterns is analogous to a design pattern. And it is helpful not only because you provide a proven solution for a specific problem, but you can also define a problem and communicate it to some others, just to make sure that we are talking about the same thing. So these enterprise integration patterns are heavily used both to define and communicate problems and to model the Apache Camel framework itself. Here we have a very common and very simple pattern. It is the content-based router, and as its name is saying, it will allow you to route messages to the correct destination based on its contents. What we mean by content, it's pretty much anything in the message exchange. We can take a look at the format, of the data type, at the message header, and so on. This is a piece of code that shows how this content-based router is done. I'm going to move to Eclipse here, and I have prepared it this way. Here we would like to route some messages based on their content. And we take a look at how the format is. Here, of course, we are going to define our KML context and embed everything that we need into that context. Here we are going to add some routes. First, we would like to consume all securities from this folder from here and to send them to a JMS queue. Here, this is a queue that we have called incoming securities. So everything that we would like to consume is sent into one single queue. And starting from this one single queue, this JMS queue, we are applying our content-based router. Here you see the essence of the content-based router. This means that depending on some condition, which in our case is the extension of the file itself, either XML or CSV, we would like to make a decision to route based on the content, or in our particular case, based on the format of the file. Here we make a choice saying that when the file is an XML, we are routing it to another JMS queue called XML securities, and when the file name has the extension CSV, we are going to route it to another queue CSV securities. From here, we are going to do some processing and to send everything to different folders. Processed XML securities here, processed CSV securities here. Just to mark what has happened, we are going to log a message to say received XML security and or received CSV security. Let's try to run this and see what is going to happen. Here, the log is telling us what it has received, CSV or XML. So this means that the content-based router has made its duty and has correctly sent everything to the appropriate JMS queue. And of course, we are going to make a verification if the messages have been routed to the correct folder. And we see here that everything that is XML has been routed to this processed XML securities folder, and everything that is CSV has been routed to this processed CSV securities. And that everything that does not conform to be either a CSV or an XML hasn't arrived to any destination. I said that we have on purpose introduced this file just to make our demonstration more clear. And we also have another demo for this securities. Here, besides what we have these queues, we are adding this JMS bad securities queue. From here, we are not going to route them to any particular folder. They will not arrive anywhere, but we are going just say that something bad has been received, and we are going just to log a message. And we are going to run this as well. We have the same folders with the same contents. In addition, here, I was saying that we are just putting this as a log. This root, this piece of root, only tells us that something bad has been received, but is not going to be processed in any way. It is just going to be consumed from the JMS queue, and then it is lost. We just put a mark that something has happened. And this has been the demo for Content-Based Router, which I was saying is one of the most common integration patterns that are widely used inside KML Apache. One step forward is to talk about another pattern. It is the message filter. It is another pattern which acts in some other way. Here we are in the need to make some filtering based on some condition. This means that we are receiving here a series of messages, and further, not everything will pass. Something will be filtered, like this photo shows, this picture shows. One message that has a particular condition will not pass. It will be filtered. This is a piece of code of how it looks like, but of course I'm going to move to the Eclipse demonstration, and I was saying that we have prepared here the demo. We have something similar. We are consuming the files from this securities folder, and we are sending absolutely everything to this incoming securities JMS queue. From here, we are going to take some decisions. We have XML securities, we have another queue of CSV securities, we have a bad securities queue. For the XML securities, here we are going to apply the filter pattern. We just say that we start to consume from the XML securities JMS queue, but we are going to filter and to pass further only what only the bonds. The bonds will be filtered, the equities will pass. We have already seen a condition of this kind. This is a filter, and this is the condition to look at a particular X path. We are going to run. So we see that the logic was, first we had the content-based router that we have talked about earlier. We have distributed everything according to the extension, XML, CSV, or something else. And from the XML queue, we have filtered only the equities. And here into the processed equities folder, we have obtained only the XML files that are equities, which in our case is one single file. We take a look at it. We have seen that here we have based the filtering condition on this XPath, which means that we take a look at security group XPath, and if it is equity, we are going to pass it. Here, the security group XPath was bond, so this one has not passed. And this has been the demo for the filtering. I'm going to clean a little in order to be able to go further. I step forward to one more enterprise integration pattern. This is the multicast, and the name may be already familiar to you. This means that we are allowed to route the same message to a number of endpoints and process them in a different way. We have something that comes on this route, and we are multicasting it. This is how it looks like. I'm going to go back to this demo. Here we show how this looks like. We have the same concept. We are consuming the files from one folder, which is the data securities one, and we are sending them to the JMS incoming securities queue. From here, we have a content-based router. And from the JMS securities, we are multicasting them, which may be the practical significance of this. We assume that we are receiving some files, we are consuming some files into some format. In this case, they are XML securities, and we are trying to multicast them to two different destinations. We may assume that there may be two departments in our company, one analysis and one archiving department, and everything will need to be routed to both destinations. This means multicast. So we are going to run this. So this works as we are expecting. So we have consumed the XML files, and we have sent them, the same ones, to two different destinations, to the analysis department and to the archiving department, just to make sure that we have the same thing that has arrived to analysis and the same thing that has arrived to the equity. And this is the multicasting enterprise integration pattern. And one more pattern in order to conclude and to complete our demonstration about enterprise integration patterns is the recipients list. This pattern allows you to route the same message to a recipient list that is dynamically calculated. What does it mean is that we may have this, of course, the same logic, but here we show how the destination is dynamically calculated. We pretend here that we are going to send everything to this analysis, and if there is some bond, we are also sending this bond to the archiving department. We may pretend into the logic that if we receive something different than a bond, meaning an equity, we need to do some analysis and then to decide probably if we need to archive. But if this is a bond, we will be sure that there will be no more other processing that is required, and we are just going to put it to archiving as well. Here we have the logic into this process. I was saying that this is a node that makes some processes, and this is the recipients list that is dynamically built. By default, the recipients list contains the analysis department. If we have a bond, we are going to add the archiving department as well. And we are going to make a run. I must have deleted these ones. And yes, I will delete them and redo. Here we see that we have dynamically built the recipient list. Here into the analysis we have both, and to do archiving we have only the bond. As I was saying, that we assume that before arriving to the archiving department, probably this equity needs some more processing. This is one way to build the recipients list, and we can also build them using a bin or a POJO. I have already mentioned that POJOs are heavily used inside the KML Apache. And here for our demo, we see that we have this bin that will tell us how to route. The logic is the same. If it is a bond, it is also archived. Otherwise, it is only analyzed, and maybe some decision will be taken later. And here is where we introduce the logic of the recipients list using a bin. We are going to run this once again. We must have the same result. Everything goes to the analysis department, to the archiving department, only the bonds are sent. And this also concludes our recipients list demo. Let's say that for the moment we have pointed out 4 very important enterprise integration patterns. They are among the most widely used. Of course, there are a lot of other integration patterns, just like the design patterns, which are widely used. From these ones, we have tried to make a small demo choosing 4 of the most important ones. And this concludes our integration patterns demonstration as well. Still have one more topic on the agenda. This is about the behavioral-driven development usage for the financial data integration application. I was saying previously that probably most of you are familiar with what is test-driven development. Test-driven development as a concept means that you would like to build an application and you would like it to be self-tested. And you will always try to add some new functionality first by adding a new test, a test that is expected to fail. Then you will write some piece of code to repair that test. You will see that after writing that piece of code, the test will pass, and you will continue the process. This is, generally speaking, the test-driven development. You always try to add some piece of code in order to get some appropriate functionality. And you always make sure by the test that the piece of code that you're adding is appropriate. It adds some value. The limitation with this test-driven development is that it always tests, it's a unit test. It tests a particular method or a particular class. It does not look at interaction between classes. This is something that is closer to what we call integration testing. And behavioral-driven development is close to this integration testing. A behavioral-driven development tries to define some expected behavior from the user and how it will act in order to do something. We are defining a scenario. We are saying that, example, you are going to the bank, you are taking your card, introducing it, asking for some money. The machine will tell you if you have funds enough, and if yes, it will return you the money. This is a real scenario that you would like to test. It is the behavior of the real user. And for financial data integration, we are trying to define some scenarios. The software tool that is used for these scenarios is the Cucumber. Cucumber is a software tool that allows us to write a scenario in what we call almost natural language. Here I have written some small scenarios. We assume that we are in the situation of importing two different securities, two different financial data information. One bond, import a bond, or import an equity. And here is something that we define, it's almost natural language. Here we pretend that we are requesting to import a particular bond that is received within a particular file, and we have some settings and some mappings. Remember that we have discussed about some settings and mappings at the beginning of our presentation when discussing the principles of financial data architectures. And then we get a new bond. This is what we are expecting, and we are expecting to have an info message within our logs. This is a possible scenario for importing a bond. This is a possible scenario for importing an equity. We are just defining the steps in almost natural language. When I say here given and, these are the preconditions. When I say then and, these are the conditions that are expected. This is an input file that is written, I said, in almost natural language. We are trying to translate these scenarios into code. And to do this, we have the opportunity to run. Here, there is something that is provided by the Cucumber API. I can run with this as input, and I am going to obtain what is called a skeleton. This is how the skeleton of my testing application will look like. Here we have some generated methods for which, of course, I will have to write my own code, which are receiving some annotations. Here you see that we are this corresponds to the steps within our scenario. We have transformed this with Cucumber rules into this skeleton. We need to write this class and to put the skeleton inside there. For the moment, I'm just copying the skeleton, putting it here, import what we need to import as well. And look, we have already obtained what is the skeleton. Here, of course, it contains nothing. From now on, it is the programmer's task to write all the logic here that will correspond to these actions. But pretending that we are able to write them, we will be able to write, to execute this test and to see that what we are going to obtain is correct. For the moment, I was saying that we are just having a skeleton. Everything remained here like it was as it was defined by the Cucumber. We are throwing exceptions everywhere. Of course, we would be able to write some code. This will take some time and is besides the scope of our presentation. But just like a principle of the behavioral-driven development and of the Cucumber software tool, I think it is pretty clear how it acts. This was what I have already presented to you, like input files. So this concludes our presentation, and please proceed with questions if you will have. So I have been asked if KML is an extension of Apache. I would say that KML is one of the products that is provided by Apache. The Apache license provides us some series of products. We know about Ant and Maven as example. And Apache is one product, one framework that is somehow similar to this, meaning it is developed and provided by the Apache consortium. Then I have been asked about where can I find the KML context class. So the KML context class is to be found within the Apache framework itself. Here I will show I have used Maven in order to manage this project. And here I have defined these dependencies that I was needed in order to, especially this one, this is the first one, the KML core, the artifact ID. So this KML context is in fact an interface that is defined within the org Apache KML package. When you need to define a context, you will need to create such a context. So this is how we have managed this. We define an object context type interface KML context, and we have this class default KML context. We define this at the beginning of our program. We add roots or something else that we need here. We start the context, meaning that the context with including its content will know how to act based on what has inside. We run it, meaning that we are waiting for 5 seconds, and at the end we are stopping it. Between this point and this point, we are having 5 seconds, and the KML context will know what to do. Will know how to act depending on the routes and the processing that are defined inside it. Here, there is a question if it is possible to get a few words about how to KML application, about how to deploy. If we want to migrate, I understand that this is the question. We have some application and we would like to move it to the KML style, to include the KML framework and to start working with it. So one method, one very good method would be to do what I have done here, to use Maven in order to define the dependencies that need, and then you will have everything brought here. You have seen that we have these libraries. These libraries need to be on the path of the project. You can add them by yourself, but better using such a tool like Apache. Here you are able to import all the needed libraries or needed jars, and you are able to use them inside your project. Of course, when you will deploy your application, you will need to deploy them together with the needed jars. Here are some other questions. If it is possible to use KML for data transportation between different hosts. What I can imagine, in order to give you a practical example, is to make the transportation, let's say, using protocols like HTTP or FTP. I think this is a good example. I was saying that KML has about 80 protocols that are already embedded. So it will not make any difference between based on the fact for where data comes from. One possible scenario is, let's say that one customer of mine is providing some data using an FTP site from where I would like to access them and to acquire them. I do some internal processing on my personal machine, and the obtained results I am going to publish on a website using HTTP. So here we have 3 hosts involved. It is a perfectly possible scenario to acquire through FTP from one host, process on my own machine, and to publish results on some other machine with HTTP. So the short answer would be yes to this question, but I was giving an example just to understand better what I was saying. Here another question is if Apache Camel supports multi-threading. Being a Java framework, of course, we need to think about multi-threading. It is possible to make some processing in parallel. This may speed up the processing. You ask if we need to care about that. What we need to care about is the fact that we are under inversion of control. So in most cases, KML Apache will know how to do its job no matter without the user's intervention. If we would like to make some parallel processing, we will be allowed to do this. But we just need to carefully design in our mind, in our ideas, if we really need something like a parallel processing. We define some conditions, we define some settings, and the Apache KML framework will take care about this. If there is something that goes wrong, we can test this using the Apache KML testing framework, and we can understand that we have designed something wrong and we can change. So the short answer is yes, but I have also given some details. Cucumber here is cucumber. Cucumber is like the cucumber that we eat. It works with Java 6 at least. I have tested it with. Of course, it works Java 7 and 8. But what I can guarantee you is that both Cucumber and Camel work with Java 6. Here, a small question, Ray, Cucumber, and I see nothing else. Somebody is asking if I can share the demo project. So it's here. I don't know what exactly this means. The answer is yes for this question. Can I stop a camel context from inside? Yes, you can do this at a particular condition. Here we have just started and stopped the camel context. And here between starting and stopping the camel context, we have waited for 5 seconds. We have waited for 5 seconds because we are assuming that Camel was going to do its job within these 5 seconds, just to copy and make the processing. If you will need to stop at a particular condition, of course, this is absolutely possible. For Alexandra Zin, yes, we can say that the KML framework is a kind of ETL tool. Its purpose is to make, I was saying, its purpose is to make integration speedy, productive, and to write less code. I was saying from the very beginning that if we take a look at something like this, we will immediately understand what is happening. You do not need to be familiar with KML in order to understand such a piece of code. Here I am asked about the fact that after we generate the skeleton, how attributes described. Let's say if I understood well, this is the skeleton. This is the skeleton that was obtained from this. Here I have imported it into a Java test file, and Cucumber will know that the method that is annotated with this will correspond to this piece of scenario. The method that is annotated with this will correspond to this piece of scenario, and so on. And Cucumber will know to execute all methods. When running a scenario, will know to execute each method based on the order within it. So when Cucumber starts to execute the scenario, we'll look at this, execute the corresponding method, we'll then look at this, and so on. Yes, running the code starts when the context starts. Before that, you are just defining. It's like if you want a comparison, you are defining a highway. You say you go from here to here. You need to have some exit here. And when I say context start, the cars are starting to effectively run on the highway. Okay. So I have answered this. I have answered this. You can stop the context practically anywhere, but in this case, the results will not be so good. It's like, let's say that we are running, to make a comparison, is like you are running a Java program at some time, you are just stopping the Java virtual machine. We can make a comparison with the consequences. If it is possible for Cucumber to convert from code to text, as far as I know, not. If you have some scenario that for which you have already written some methods, I'm not aware of being able to import somehow and to get a scenario of this kind. You just need to define your scenarios and to associate your methods with the code itself. From text to code. So here we have, I'm not sure what are you thinking about, but I understand. I'll try an answer that hopefully will be what you're expecting. So here, when you write a scenario in text mode, you are defining the steps almost in plain words, in natural language. I say given. When I say given, I am defining a condition. I say given a fact, given the fact that I am trying to import a bond, and given the fact that I am going to a teller machine, I am trying to extract some money. These are some preconditions. You will not be able to write your own the code directly, but you will be able to obtain this skeleton to know that this, for example, this method will be the one that needs to include the logic of the fact that you have requested to import a bond with code. So you are just getting the skeleton. What needs to go here, 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 and so on is something that you, as a programmer, will need to write by yourself. You will need to effectively say what means in terms of business logic and in terms of your own code, what it means that you do this step or this step. Problems, of course, somebody is asking if there are problems. Of course, there are problems. One of the most common problems is that you are not getting what you are expecting. You are trying to import some data to transform it, and you are looking at the results. And one of the most common problems is that the tests are failing, and you need to repair them. If you are talking about KML itself, I would say that it is a pretty stable framework. So we did not face failures or major problems, if that was the question about. Mihail Eisman is asking about some other, about Gherkin. Yes, I know about Gherkin. This is an alternative special language, but we did not do this. We have just done this cucumber scenarios. Any more questions? If there are no other questions, I think we are done with my presentation.